Okay, I think I'm ready. I think I'm ready, so I can talk about programming blockchain, preparation for programming blockchain. All right, let me do some volume control. So I think I'm streaming all right. And let me see this part. So preparation for blockchain programming. I have uploaded the lecture notes right here. So let's take a look at that lecture note. So it is right here. So we can do the, all right. So let me talk about this. Let me see if I'm okay with the, all right, so it's working. So let me do it. All right. So preparation for blockchain programming. So throughout the whole course, we will utilize these materials. So basically, purpose of this lecture is to introduction of GIST Riverbanks testnet. We have a test network of Bitcoin. You can download this BIT-ECC, which is a D-secure blockchain made from InfoNet GIST. And then we can use this testnet to test out the Bitcoin APIs. And then you can do some example programming. You can compile your modification to Bitcoin protocol. And you can run your Bitcoin core into your local machine, and then you can test out if your upgrade is meaningful or is your upgrade making sense. You can test out all these things in your own environment or using our test net. So that's the purpose of this lecture. So in order to do that, I want you to go through the instruction page, and then you can do step-by-step manner download the instruction you need to follow, and then you download from the GitHub repository. You just need to follow all these instructions so that you can you reproduce the result within your working environment stored in your local computer. All right, so I will talk about installation of a virtual machine and Linux. It's supposed to be Linux, so let me open up. So that's the actual Word file, so I need to upgrade that one. Linux local machine and Linux operating system into your local Windows machine, and then in the process you will download and install Anaconda, Python, and C++. Okay, and then you will install BIT-ECC, which is the new Bitcoin protocol my lab has produced in the past, and you want to install this core into your local machine, and within your local machine you can test the Bitcoin APIs. The API of Bitcoin ECC API. Bitcoin ECC is almost this. I mean, 99%. The same with the Bitcoin core, because we have hard fork, we have done the hard fork of the Bitcoin protocol. The only part that we have changed is the consensus part on the proof of work. So you can learn about Bitcoin programming, and then you can learn about this test network. And we will do this throughout the whole course. So I want you to pay attention to download and run these protocols within your local machine. And then I'll give you homeworks and projects based on these as well. Okay. So what do you mean by this secure blockchain? This secure blockchain is made by my lab in the past, and it is a blockchain aiming to achieve decentralization and security. So emphasis is given to decentralization and security. Security here means actually we will continue to use proof of work. We will we will improve the proof of work toward the decentralization. I believe the proof of work system is the most secure protocol for blockchain. That is the reason that I put emphasis on these two. Rather, this is going against some of the very recent approaches in blockchain community, where people have emphasized the speed of transactions, how quickly the blockchain, how quickly the new block can be generated, how many transactions can be stored into a block. So basically, in order to increase the transaction speed, you can work on two things. You can increase the block size, and then you can decrease the block generation time, block generation interval. So from 10 minutes to 1 minute, 1 minute to 1 second, you can improve, increase the speed of block generations, and you can also increase the amount of transactions, number of transactions within each block. So that way you can increase the transaction speed, which we call this scaling solutions. But when you do that, security goes bad. And then when you do this, you have to give up proof of work. And when you give up proof of work, then your blockchain is no longer secure. That's what I mean. That's what I believe. This all has to be tested out with the new inventions. And then in the long run, we need to compete with each other. And then the one that survives out of this competition will be the true winner. But that's why I use the word believe at the moment. But I think the proof of work is the most innovative system that I have seen in my research career, rather than proof of stakes or other proof of X schemes. I don't think they are very innovative. So I want to stick with the proof of work idea, but the current proof of work idea can be improved. And then I want to push new technology into the areas where the proof of work can be improved. Okay, so that's my direction. So the decentralization is sought by anti-ASIC consensus algorithm in our case. ASIC chips are the culprit of centralization of the mining market. ASIC chips are very expensive, and then those corporations who can buy lots of these chips, and then such company can dominate the mining market. And anti-ASIC property is achieved by our new algorithm by utilizing error correction codes in the proof of work. Basically, we have used an error correction code called low density penalty check codes to augment the secure hash function. and have made a new POW called ECC POW. And this ECC POW has a new property, which is to make the crypto puzzles ever changing. So it is the crypto puzzle generation system changes from one block to the other, and as a result, it becomes almost impossible for one to make an ASIC chip. Okay, so since there is no ASIC chip, then there is no corporation who can amass large amount of ASIC chips and then dominate the mining market. So that's our approach. And using ECC POW, security is maintained because it is utilizing proof of work system, which I believe, again, is the most secure consensus algorithm ever invented in the human history. So I will stick with it since, but since I have improved the decentralization aspect of the proof of work by having time variant proof of work puzzle generation system. So I believe I can. We have better blockchain system built better in terms of comparing to the Bitcoin blockchain. All right. So currently we have two D-Secure blockchain projects. One is Bitcoin ECC POW. We call it BIT-ECC. And it is a new Bitcoin whose consensus part is replaced with ECC POW. And ETEC, which is the whose consensus part is it is a Ethereum it is a new Ethereum blockchain core whose consensus part is replaced with the ECC POW. All right. Currently, these two packages are downloadable from our GitHub repository right here. And if you go there, you have a pointer to the papers that we have written for each system. And then you can see papers for double spending analysis. And then you can have a paper for Ethereum ECC POW and so on. And then you can also visit for papers. You can also visit our publications page in the internet in our labs internet. Okay, so if you go there, you can find out the papers to download so that you can read about them. Okay, and so the Bitcoin GitHub, our GitHub page shows several other supporting directories such as BIT-ECC. You can go here, you can download the code which is written in C++, and then you can use this protocol. You can download into your local machine, and then build protocol, and then you run the BIT-ECC server in your local machine, and then you can have your local computer to join the BIT-ECC blockchain network, and so on. And then there are instructions, so you can utilize to do that. And Bitcoin ECC block generation program, and this is the program that you can follow, and you can go to the GitHub page and then download this one. So for example, I will show you, let's say ECC crypto ECC, crypto ECC. You go there, and it's right here, and this is on ECC LDPC, and you go there, then you have all these pages and repositories. This one is for Bitcoin ECC, so BIT-ECC. This one is ETH, and this one is the Bitcoin ECC block generation program. So once you install this into your computer and run this one, your computer will work as a block generator of BIT-ECC network. So basically, you can make your computer to run as a mining node for BIT-ECC blockchain network. So that's what I'm saying. So if you go there, then you have these programs. If you download these programs, then you can join the BIT-ECC network as the miner. Right, so let me enable the link, hyperlink, so that you guys can go directly there, right? And so on. And let's move on to the next item. So this is the repository that I have shown you a moment ago. This secure blockchain. It has Bitcoin, ECC, Ether ECC, block generation. And then when you go there, you have a Explorer, which is monitoring the blockchain of the BIT-ECC network. It shows the peer nodes. It shows the block content, so basically transactions. It shows you the height of the blockchain. It shows you each block. Each block has a block header and a block body. It shows you everything, and then it talks about wallet, and then the basics on the ECC POW, which is made of LVPC code, and so on. All right, so that's that part. And there is an Explorer program, like I told you, and this Explorer program is for BIT-ECC blockchain, which is made from a Bitcoin Explorer. Using this program, you can browse blocks and view block details. So maybe we can take a look at this this one right here. So let's see block details. So let's see. Right. So I will open up a new one. So Explorer Riverbanks. So I have a BIT-ECC blockchain core running for this test network. So this test network is just Riverbanks testnet. It shows you hash rate, network summary here, total number of transactions, difficulty, block size, blockchain size, and the latest blocks, and these transaction status. For example, if you click the the most recent block, if you take a look at the most recent block, it was generated in March 21st. The time is 23rd, 26th, 29th. So that is the hour, minute, and second. This is the universal time, so it has a 9-hour difference with the current Korean time. So this was made. So currently it is 8 o'clock 28. So it was made a couple of minutes ago. couple of minutes ago. So 2 minutes ago from this time point. So age is given right here. 31 seconds before, actually. Okay, I see. And then if you click this one of this block number, so that is a block number 34,983. That is the block hash. And in this block, you have a timestamp given right here, number of transaction, one transaction. So it only has the Coinbase transaction. And the next block, previous block is written right here. So I think there is the next block was generated while we were talking. So let's take a look at, let's click this one. See, aha, see, there is a, so this is most recent block. And then previous, if I click this one, we will go back to 34,983, the block, and so on. And the Coinbase transaction says this is a new coin generated, which is 50 BTC, and it was given to this node right here. All right, so it was given to this address, which is one of the addresses that we are testing, so if we next block, and if you click the previous block, it shows you that one, right? Shows you this one right here, all right? And then if we go to further previous block, which is 34,982, it goes to the previous block, so and so on and so on. Keep on going, keep on lowering the block height, block number, as you can see, and then it shows you the previous blocks and so on. So that's the block explorer. Block explorer shows you, the blockchain, and you can take a look at the peers of this blockchain network. There are currently this many nodes working together to generate blocks. All right, so as you download this protocol and run into your local machine, and if you have an IP address assigned to your local machine, then your node, your computer can join this open network and become part of the P2P network. All right, so that's about Explorer. So we have this Explorer up and running, and then we will use this blockchain network throughout the course. And so I want you to study this like part of the lecture notes very carefully. You need to download and execute build the core and then execute the core in your local machine. And ECC POW is discussed in this repository, and you can download the program from this repository, and then you can test out the workings of the ECC POW within your local machine. And WordLess are given right here. Currently, we have a PC version that is working for the test network, but we don't have the Android or iOS wallet app working as of yet. So a wallet application for Android or iOS phones is not ready as of today. So this could be one possible project for the course, so that you guys can work on this wallet that is given for Bitcoin, and then you can modify. You can basically change the network ID and generate, the Genesis block, and you can change the block header of BIT-ECC, blockchain, update it to this wallet. Then you can run, wallets targeted to work for BIT-ECC network. Then then it will be a success, for example. And we have a ETEC, Ethereum Ecc POW, a protocol, for Ethereum version of the Bitcoin is ECC POW. So basically, when you go to this official repository, then you can download ETEC, and then you can do the same as you can do with the BIT-ECC blockchain network. So basically, you can start your own BIT-ECC blockchain using this protocol. You can see our paper published right here in order to learn more about ETEC network. Okay, so here is the our testnet. So LVnet is a tech venture launched by me in January 2020. So this is a GIST tech venture, professor tech venture approved by GIST. The name of the venture comes from two words, liberty and advance. And basically the aim of LVnet is to introduce the lab technologies developed by my research team. And if you want to know more about LVnet, you can follow this link. And LV has started testing BIT-ECC protocol extensively. The Explorer is running at this address. It shows 34,890. The block height as the block height on this date, basically yesterday, right? But you have seen the most current one a moment ago. This is a test net for BIT-ECC protocol, which can be downloaded from here. And when you go to this Bitcoin ECC repository, there are many versions, but the most recent version that we are working on is this version, ECC 0.1.2. And we will use this LVnet to learn Bitcoin protocols and Bitcoin blockchains. Basically, these APIs are almost the same with Bitcoin APIs, because we copied Bitcoin APIs, and the only part that we changed is the consensus part regarding ECC POW. So that's, since they are almost the same, we can utilize BIT-ECC for our study of Bitcoin. And at the same time, we can improve BIT-ECC protocol. And then we can do different experiments for improvement, right? Just like what we have done with ECC POW, which is an extension to Bitcoin, original Bitcoin protocol, in terms of time varying proof of work puzzle generation. Okay, so and in this semester you can change the Bitcoin schedule, Bitcoin generation schedule. You can change the block generation time from 10 minutes to 20 minutes or 10 minutes to 1 minute. You can change it you can change the block Bitcoin generation schedule. So instead of halving of reward every 4 years, you can change it to every 2 years, or every 1 year you can halve the amount of Bitcoin reward. And then you can do all these different kinds of experiments using this platform. So that since we have a different network ID and different genesis block, the experiment that we do do not interfere with the original Bitcoin blockchain. All right, so there are 9 documents you can find and use to start learning about the LVnet, and you can use them to learn the Bitcoin protocol, and the LVnet currently up and running is based on this protocol, like I told you. And then here you can talk about the Bitcoin ECC, BIT-ECC, download and installation. So basically, I want you to follow all these, procedures. Basically, here you need to set up your environment. So if you are working on Linux, you can skip the installation of a VMware part. But if you use Windows, you first need to install virtual machine workstation into your Windows, and then within VM workstation, you will need to install Linux operating system. And within the Linux operating system, you can follow our documentation, and all you have to do is to follow these procedures. So this environmental setup and installation and learning, you can find it right here in the blockchain repository, which is given right here. And go there and go here, Bitcoin ECC, and instead of master, you go to ECC 0.1.2, click there, then you go to the repository there, and then here you find the document. You go to document, you have a Bitcoin ECC document. There you have you have this file, Bitcoin installation and testing file, this one. And let's take a look at this. And if you click it, it'll show you environmental setup, installation, and testing. So let me copy this link, and then let me put the hyperlink there, so that just by clicking it, you can go there. All right. And then when you get into this document, all you have to do is follow the instruction given there, and then you will be able to download the BIT-ECC protocol, install it into your local Linux machine, and then in your local Linux machine, you can test your private network. Basically, you can run BIT-ECC and run a BIT-ECC server. And you can use this server to see basic functions of a BIT-ECC server, such as sending transaction, generating blocks, verifying the inclusion of a sent transaction in a published block, and so on and so on. There are lots of APIs that you can utilize defined in the BIT-ECC protocol. And to start you can also start your own BIT-ECC blockchain. In order to do that, you need to generate a Genesis block, and then you hard code this Genesis block into your blockchain core, and then you set up a new network ID, port number, etc. And then you can start your own blockchain network. You can also utilize the currently running Testnet, LVnet, for learning the Bitcoin protocols in this class, right? And then you can talk about, we can move on to the generate the Genesis block of the BIT-ECC protocol. Basically, in order to do that, you have to do some modification to the source file. Here you have a chain parameter CPP file, and then you need to do some modification after you have generated Genesis block. And one of my students have done the programming, and he left a message on the Genesis block for the current version. See if you can find it. And the BIT-ECC block generation program, basically this is a mining program. So once you run the BIT-ECC server in your local machine, and you run this mining algorithm in your local machine, then your local machine works as a mining node. So you can, be a part of the mining network. And in order to get the mining reward, you need to create a new address for you, so that you can have the block generation reward kept yourself. Okay, and there is a wallet part, there is an explorer part, there is some programming details to run a new blockchain. And in order to new blockchain, if you have a certain number of seed nodes hard coded into the Bitcoin core, it will be helpful. And then this one show you how to do that. All right, so basically that's it for today. And for the rest of this document is the repetition of the documents that I have uploaded in the GitHub. All right, so I think I'm done for preparation for blockchain programming. I want you to follow this instruction and then install BIT-ECC server into your local machine, and then do the do the verification of APIs that you have available in your server to make sure that your server installation is done correctly. Okay, so having said that, I will start my presentation, my talk, my lecture right here. Okay.